Hey guys, this is a video run through of your homework. Question 1 is, what is your average velocity? And we answer this pretty simply. In class you should have learned that your average velocity is equal to the total distance you traveled divided by the amount of time it took you. So say that you went 60 miles in 1 hour, your average velocity would be 60 miles per hour. The average velocity is equal to our total distance over our total time, and our total distance was what? 50 yards. Our total time was however long it took you to go those 50 yards. If you don't have a time in the Google Doc that I shared with you, there is at the very bottom an average time, and just calculate that. What is question 2? Question 2 says, what was your average acceleration? A little bit more difficult. Here's why it requires our kinematic equation. What is our kinematic equation? Well, it'll take me a while to write down. But it looks a lot like this, right? Our df, our final distance, equals do, our original distance, plus vo, our original velocity, times time, plus 1/2 a, our acceleration, t squared. Looks complicated, doesn't have to be. In this case, it's not. Why? What speed were you going when you started running? You weren't. You were stationary, right? So because you were stationary, because your initial velocity v naught was 0, we're just going to cross it out. Just like that. Just cross it out. That simple. What was your original distance? 0. Let's cross it out. It doesn't matter to us. So what we're left with is our final distance, df. What was that, by the way? 50 yards. Equals 1/2 our acceleration times the time it took us to run it squared. Okay. Still looks daunting, right? But what I have to do is isolate this a variable. That's why I underlined it. This is what we're looking for. So the way we do that is by moving this t squared and this 1/2 to our other side of our equation. We do that by doing the same thing to both sides of our equation. We have to do that. That's what you do every time you're working with equations ever. What's that? Same thing, both sides, every time, always. Okay. So step 1, I'm going to get rid of this 1/2. How? I'm going to multiply both sides by 2. Okay, so that means that I end up with this. I've multiplied this side by 2. 50 yards times 2 is 100 yards. 1/2 of a thing times 2 is just the whole thing, right? Like half a pie. If you have 2 halves, you have a whole. Pretty simple. Okie doke. Then we're going to get rid of this t squared by dividing both sides by it. If you feel weird about dividing by variables, put those feelings aside. Just get over them. Somehow, some way, we have to do this. Okay? So we end up with our final formula here. 100 yards divided by t squared equals a. This is what we're going to be plugging your time into. Why? Because it gives us our answer. A, that's what we want. Acceleration. Hooray! Okay, so to get your answer, you're simply going to divide 100 yards by your time squared. So say that I ran the race in 5 seconds, right? I didn't, but suppose I did. So that I have 100 yards over t squared. I said that my t is 5, so I get 100 yards over 25 seconds squared gives me 4 yards per second squared That is my hypothetical answer if I were running that quickly. Now, you will of course be using calculators, so you won't have to use hypothetical numbers. Just plug in whatever number you're using and get your answer and show your work. That's what I'm grading you on. Question 3, how much force it took you to run that quickly? 3, how much average force it took you to run that quickly? So, how do we find our force? Well, this guy named Isaac Newton said, force equals mass times acceleration, right? Which law is that? It's Newton's second law. I hope you said that at the screen. That's my goal. That's why I left that pause in there. Newton's second law, F equals ma. What's Newton's second law? F equals ma. Remember this, please. Okay, we have our acceleration. We got it from problem 2. So all we need to do to find how much force you were using is by multiplying it by your mass. So how do we find your mass? You know how much you weigh, and weight and mass are really closely linked, but they're not the same thing. So take how much you weigh in pounds, go to Google and type in I weigh blah blah blah, or don't write I weigh, just write in the number followed by pounds, space, in, space, kg, equals, enter, and it'll give you an answer. I'm going to send you a screenshot to show you. It's really easy. Just put it into Google. Google does all the work for you. When you have your mass in kilograms, multiply it by the acceleration that we experimentally derived, and that will give you your average force. And that's it. For example, I said that my acceleration was 4 yards per second squared. I'm going to say that 4 yards per second squared is roughly equal to 4 meters per second squared. All right? Kind of cheating there, but that's what I'm doing. My acceleration was 4 yards per second squared. It's almost 4 meters per second squared, right? So I'm just, see these wiggly equal signs? That means it's kind of like that, right? That's what we're doing. So that's my acceleration. My mass is, I think it was about 72 kilograms. So that means that the force that I needed to accelerate that quickly was 72 kilograms times 4 meters per second squared. 4 times 72 is 288 newtons. And that's how strongly I would need to push against the earth in order to run as quickly as I supposedly did. And that's it. That's it. You're done. That's all you got to do. Okay? Bye.